Okay, tonight we're going to work on equivalent fractions. That is, equivalent is the same as equal. Okay, so equal fractions. Alright, so fractions are often used to describe the relationship between part of a set of objects and the whole. Remember, we talked a little bit about part, whole last night and yesterday. Or today, I'm sorry. Alright, so we've got 2 out of 5 counters are red. So you'll have your counters here in front of you. So we're going to work with those. So make sure if you don't have those out, you need to get them out. In our case, it's going to be red and yellow, not red and blue, but you kind of get the picture. Alright, so we've got 2 out of 5 counters are red. So 2 is the part, 5 would be the whole. So our fraction is going to look like this. It's going to look, the part, it goes on the top in the numerator, and the whole goes on the bottom in the denominator. It describes what the fraction, it describes a fraction of red counters. Alright, over here we've got 3 out of 5 counters are blue. So the part is 3, counters, or the 5 is the whole. That's the total number of counters that we have. And we would write our fraction as 3 over 5. So the part, again, goes in the numerator, and then the whole goes into the denominator. Okay, so looking at this set of counters, we've got 1, 2, 3, 4 reds, and 1, 2, 3 blues. Okay, and what it's asking us is what fraction of the set is red. Okay, so first of all, I need to count how many total chips I have, or total counters. So I have 4 reds and 3 blues. So that gives me a total of 7 counters. So my fraction is going to be a 7. My whole number is a 7. Okay, whole number is going to be the 7. So I can automatically cross out the ones with the denominator as 3. So that leaves me with 4 over 7 or 3 over 7 here. And remember, it's asking me how many of the reds. Now I know I have 4 reds. My whole number is 7. So my answer is going to be 4 over 7. Alright, down here it's asking what fraction of the set is blue. Okay, again, I have a whole number, so my denominator is going to be 7 because my total amount of counters I have is 7. And I know that I have 3 blues, so my part is going to be 3. So it'll be 3 over 7. Alright, so fractions that share the same relationship between part and whole are called equivalent fractions. Again, equal. Equivalent or equal. So here I have a circle with 3 halves, or 3 parts. So it's broken up into thirds. And I have 1 yellow here, and then 2 blues. So that's why I have my part here. It's asking me the yellow, obviously. So my yellow is 1 over total. So 1 out of 3 are yellow. Over here, I have the same size circle, but it's broken up into smaller pieces. So I have a total of 1, 2, 3, 4, 5, 6 pieces now. Okay, so I have 6 pieces total. Remember, same size circle, just broken up into smaller pieces. So I have 2 yellows and 4 blues. Okay, so my whole pie is going to be 6. And I have 2 yellows out of that, which is my parts. Okay, now 1/3 and 2/6 are equal. They're equivalent fractions. Now let's figure out how to work out equivalent fractions. So we have our counters in front of us. So you are going to model what we're doing here. So you're going to have 2 red ones, and then this will be yellow. Okay, so go ahead and bring that out. So you should have 2 red counters and 1 yellow counter. Alright, and that is going to show us our 2/3 fraction. because 2 of those counters are going to be red out of the total 3 counters that we have. Okay, what we're going to do is we're just going to reproduce that. So I want you to get 2 more red counters. So this is our first set. Then I want you to get 2 more red counters out, and I'm going to make a third set and 1 more yellow counter. So it's going to look like that. And then I'm going to get 2 more red counters out and 1 more yellow counter out. So now I have 3 sets of 2 red counters and 1 yellow counter. That is going to give us an equivalent fraction. But now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 total counters. And how many of those counters are going to be red? Got 1, 2, 3, 4, 5, 6 of those are red. So now I've just made an equivalent fraction. I took the original set of counters that I had and I just duplicated them, kind of like multiplication. So 6 out of the 9 of the larger group is red. So 2/3 and 6/9 are equivalent fractions. All right, so we're going to use counters again to generate fractions equivalent to 3/4. Okay, so with your counters, I want you to duplicate that. So you're going to have 3 red counters and 1 yellow counter. So this is our third 3/4 right here. Okay, then you're going to duplicate that. Okay, Miss Friendly is going to duplicate it 2 times. Okay, so now I have 3 total groups of the same thing. Go ahead and take a minute to do the same thing with yours. You can do it 2 times like I'm doing for a total of 3 groups, or you can do it 1 other time, or you can do it 4 other times. Ultimately, you can do as many times as you want to get equivalent fractions. So what I'm going to do is I'm going to add these 4 plus these 4 plus these 4 to get my whole number. Okay, so I have 4, 8, and 12. So my whole is going to be 12. And then I want to find out how many of those are red out of the 12. So I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 12 are whole. 9 out of 12 are red. So my 3/4, I've now made an equivalent fraction of 9/12. Okay. Here again, we've got 6 out of the 10 counters are red. So I have a total of 10 counters. I basically have 2 groups of 5 counters, which 2 times 5 is 10. Okay. So in the model shown, 3 out of every group of 5 counters are red. Okay. This would be 3/5. This would be 3/5. Okay. So therefore, 6 out of 10 and 3/5 are equivalent fractions. Alright, so to find equivalent fractions, you're going to multiply or divide the numerator and the denominator by the same non-zero. That means anything number but 0. Okay, so for example, I've got 1/2 equals blank over 10. I need to figure out what is the tens here. So now I need to figure out how many times does 2 go into 10. 2 goes into 10 5 times. Okay, so 2 times 5 is 10. Okay, so what I'm going to do on the bottom, I'm going to do on the top. So that leaves me with a fraction of 5/10. Okay, so basically that's what it's showing us here. Since 2 times 5 is 10, we're going to multiply the top number of the numerator and the bottom number of the denominator by 5. Whatever you do to the bottom or to the top, you have to do to the opposite side. Okay, so on your notebook, I want you to go ahead and practice these here. So you are going to use multiplication to complete equivalent fractions. Go ahead and pause the video and do that, and then when you come back, we'll look at the answers and I will walk you through how to do that. Okay, so now that you've gotten that, first thing I need to do is I need to figure out how many times 3 goes into 9. So what times 3 equals 9? Then we'll come up with 3 here. So 3 times 3 equals 9. So I'm going to multiply, since I multiplied 3 on the bottom, I'm going to multiply 3 on the top. So that gives us 3 over 9, or 3/9. Yep. Yay, Miss Friendly's correct. Everybody give me a round of applause. Okay, so again, we're going to do the same thing down here. So I've got 4 into 16. So what times 4 equals 16? And I'm going to know that 4 times 4 equals 16. So since I'm multiplying 4 on the bottom, I got to multiply 4 on the top, which gives me 4/16. All right, and finally, oh, they switched up on us. Okay, so now I need to figure out how many times 1 goes into 16. Okay, so what times 1 equals 16? Well, that's 16. So now I got to do the same thing on the bottom. 2 times 16 is 32. Good. So an equivalent fraction to 1/2 is 16 over 32. Okay, so to find equivalent fractions, you're going to multiply or divide the numerator and the denominator by the same non-zero number. Okay, as you notice on the bottom, or the third on our practice, it had the number similar to this, where we had the numerator there, but not the denominator. Okay, so what you're going to do is you're going to basically do the opposite. In this case, I've got the bigger numbers over here, and I want to make it into a smaller fraction. So what am I going to do? I'm going to divide. Okay, that's what I'm going to do. So I'm going to take 12/16, I'm going to rewrite it over here, equals 6 over, we don't know. All right, so the first thing I need to do is I'm just going to go backwards. So how many times does 6 go into 12, or 12 divided by 6, or what times 6 equals 12? And I'm going to know 12 divided by 2 equals 6. What am I going to do on the top? I'm also going to do, sorry, on the bottom. So I'm going to go 6 divided by 2 is 8. Okay, let's take a look. All right, so 12 divided by 2 is 6. Divide the numerator and the denominator by 2. Okay, so let's practice that. Go ahead and pause the video. And you're going to work on these 3 practice problems using division. Okay, so now that you've did that, let's take a look at what we got going here. So I have numbers here. So I need to know 30 divided by what equals 5. Okay, so, or I can go 5 times what over here equals 30. Okay, some of you that are not as strong as division, you can go back to doing multiplication. So 5 times 6 is 30, so I'm going to go 30 divided by 6 equals 5. Okay, what I got to do on the bottom, got to do on the top. So I'm going to go 6 divided by 6 equals 1. Okay, so it'd be 1/5. Okay, so down here, I got a number on the bottom here. So I need to go 15 divided by what equals 3. Okay, so I can count my 3s and go 3, 6, 9, 12, 15. So 3 times 5 is 15. So 15 divided by 5 is 3. What I do on the bottom, I'm going to have to do on the top. So 10 divided by 5 is 2. So 2/3. All right, and finally down here, switched it up again on us. So we're just going to start, oh, I'm sorry, they didn't switch it up on us. So we're going to start down here again. 24 divided by what equals 4? You can count by 4 so you get to 24 to figure out your multiplication. So 24 divided by 6 is 4. So I'm going to, what I do on the bottom, I'm going to have to do on the top. So 18 divided by 6 is 3. So I got 3/4. Okay, so now that we have gotten equivalent fractions, we also need to know how to write fractions in simplest form, which is basically taking a big fraction and dividing it down until I can't divide it anymore. Okay, so if we have 18/24 and I need to divide it until I can't divide it anymore to get the simplest form. So you're going to divide by common factors. Okay, I can divide 18 and 24 by 2. So 2 is a common factor of 18 and 24. 3 is also a common factor of 18 and 24. Okay, so in this case, what they did is they took 18 and 24 and divided it by 2. Okay, which gave us 9 over 12. Okay, so 9 and 12 can both be divided by 3s. So they took 9 divided by 3, which is 3, and 12 divided by 3, which is 4, and gives us 3/4. Okay. And if you hear greatest common factor, it's basically these two numbers, or however many times you have to divide it down, plus each other. Okay, so the greatest common factor of this, or not plus, but times each other. So 2 times 3 is 6. So if you were looking at 1824 and you couldn't figure out that you can divide 18 by 6 and 24 by 6 and get down to 3/4, then you just start with what you know. So start with divided by 2. Okay, and then you can go with divided by 3, and then just times those two together, and that will give you the greatest common factor. I don't believe you have to know that right now, but it's good to be exposed to it, so that if you're ever asked how to figure out a greatest common factor, that's what you would do. But basically, I'm okay if you do it like this. Divide and divide and divide until you can't divide anymore in common. Okay, so let's practice doing in simplest form. I'm going to do these with you because it wasn't really self-explanatory. So if I got 6 and 15, what can I divide 6 and 15 by? Can I do it by 2s? 2 will go into 6 3 times. Can 2 go into 15 though? No. Okay, so I can't start by 2. So let's move up to 3s. Can 3 go into 6? Yes, 3 can go into 6 2 times. Can 3 go into 15? Yes. Okay, so I'm going to divide by 3. And that's going to give me 2/5. Can I divide any further? 2 and 5 are both prime numbers, and they're only divisible by itself, so I can't go any further with that. Okay, 2/5. All right, so I've got 28 over 36. This one's kind of hard, so again, you can start with just your 2's. For those of you that struggle with division and multiplication, just start with 2's. So if I divide here by 2, can I go 28 and 36? Yes. Okay, so 2 into 28 is going to give me 14. 2 into 36 is going to give me 18. Okay. Can I go any further? Can I divide any further? Yes, 14 and 18 are not prime numbers, so I can keep going. Now, since I've got even numbers still, I can probably still go by 2's. Obviously, if you find a bigger number in common, then you go with that. But if you don't, or you don't know how to do that, then just go with what you know. Start with 2's. All right, so 14 divided by 2 is 7. 18 divided by 2 is 9, and I have 2 prime numbers, so I can't go any further. All right, and down here I've got 75 over 100. 75 over 100. So I've got 5s, something that ends with 5, so 75. So I know I can't go with 2's. I know I can't go with 3's, so I'm probably going to start with 5's. So I can multiply down by 5's if I want to. But I also know by looking at this, it kind of looks like money. And I know that quarters or 25s can go into that. So let me do it both ways. So for those of you that want to just go by 5's, you're going to go by 5's. That brings us down to, goes in there once. So 25, so that's 15, right? I think. And then 20, okay, I can divide by 5 again. That's going to give me 3/4, okay? So you can do it that way, or let's rewrite it over here. So 75 over 100. I know that 25 can be divided into both of these. Okay, so 25 will go into 75. Let's see, 25, 50, 75 will go in 3 times. And then 25, 50, 75, 100 can go in 4 times. Okay, same number. Just took me quicker to use the bigger number than the smaller numbers, but you get the same result. 3/4. Okay, so this is a copy of our practice book page. We'll do a couple on our own. We didn't really talk much about number lines. We will go over that tomorrow or the next day. So looking at the models, we'll do the number lines together so you can kind of see how to do that right. Equivalent fractions for each model. So here I've got 2/8, an equivalent fraction to 2/8 would be, sorry, I lost my train of thought. Oh, they have 6/8 here. Sorry, I can't just pick randomly. All right, so 6/8. So I need to write an equivalent fraction for 6/8. Okay, but I don't have another number here to reference. So what I can do is I can pick any number that I want to multiply by, as long as I multiply the top and the bottom by the same number. So I'm going to multiply by 2. Okay, so 6 times 2 is 12. 8 times 2 is 16. So an equivalent fraction would be 12 over 16. Okay. For number 2, you've got, I'll start you off with the fraction. There's 3 shaded parts over 5 total. Okay. So you're going to multiply by those 2 numbers by something specific, and you can find an equivalent fraction. Okay. Here, count as many bars as you have. That would be your whole. Count the shaded part. That's going to be your part, and start with that and find an equivalent fraction. All right, and if Miss Fernley read directions, you're supposed to write 2 equivalent fractions for each model. So make sure that you write another fraction for this one, total of 2 for this one, and total of 2 for this one. All right, so write 2 equivalent fractions for each. Here it gives us a fraction, and we need to find an equivalent fraction. Let's start with number 5. I'm just going to go by 2 because that's the easiest. 2 times 2 is 4. 3 times 2 is 6, so 4/6 would be one of them. Okay, and then I can also go 2 times 3. 2 times 3 is 6, and 3 times 3 is 9. So 4/6 and 6/9 are both equivalent fractions for 2/3. All right, so down here they want to know whether if the fractions are equivalent, right? Yes or no. Let's start with number 9. If I go 2 into 8, so 2 times 4 is 8. Is 6 times 4 24? Yes, it is. So yes, that would be an equivalent fraction. So figure out either the numerator or the denominator, if it can go into or multiply or divide either one, and then see if the bottom does the same. I'll do one more with you. Let's look at number 11. So I've got 6 and 2 and 12 and 3. Well, let's choose the numerator, 6 and 2. How many times can 2 go into 6? Or 6 divided by what equals 2? Okay, well 6 divided by 3 equals 2. So does 12 divided by 3 equal 3? No, so those are not equivalent fractions. Alright, so tell whether the fraction is in simplest form. Tell whether the fraction is in simplest form. If not, write it in simplest form. Let's choose one that's not already prime. All right, I've got 18 over 20. Those are not prime numbers, so it is not a simplified fraction already. Let's divide by 2, because that's easiest. Okay, 18 divided by 2 is 9. Over 20 divided by 2 is 10. 9 is a prime number, so I can't go any further with that one. All right, finding the missing numerator or denominator, working with equivalent fractions, kind of like we did at the beginning of this lesson. So I'm going to go 8 times what equals 24? Well, 8 times 3 is 24, so 2 times 3 is 6, so it's 6 over 24. Okay, for the word problems, Cheryl's cat had a litter of kittens. 3 are white and 6 are gray. So how many total do I have? What's my whole number? 9. Okay. What fraction of Cheryl's kittens are white? All right, I'll let you finish that one. So you figure out how many of those are white, and then you need to make sure that you do it in simplest form. 21. Mario ate 4 hot dogs. One of them had mustard on it, and the rest were plain. So how many total hot dogs? Okay, so that's going to be my whole number on the bottom. That's my denominator. One of them had mustard on it, and the rest were plain. What fraction of Mario's hot dogs were plain? Write an equivalent fraction for this amount. Okay, so I'm going to, first of all, find out how many of those were plain. Okay, and then I'm going to make another fraction, an equivalent fraction. All right, you can solve 22 and 23 on your own. So for your WSQ, I want you to explain to me 2 ways that you would find an equivalent fraction for 4/16. Okay, 2 ways. Remember we talked about 2 ways of doing that. I want you to explain to me what those 2 ways are. If you have to go back and rewatch the video, go for it. Have a good night. We'll see you in the morning.